Well, today we have gathered to discuss about the questions based upon JEE main pattern upon the topic trigonometric functions. So let's begin. The first question is asking you to compute the value of such a trigonometric expression. Let's see what is it. Thrice of sin x minus cos x whole to the power 4 plus 6 times sin x plus cos x whole square plus 4 times sin 6x plus cos 6x. Fine? Let's see how to proceed. Well, over here it's natural to write it as sin x minus cos x whole square and then again whole square, right? Because we know the identity of a minus b whole square. Then you have plus 6. Now already over here you have a plus b whole square, which is a square plus b square plus twice of sin x cos x, right? Next you have plus 4. Now over here the natural intuition is that it can be written as a cube plus b cube. So for that I am going to write it as sin square x whole cube plus cos square x whole cube. Fine? Now let's proceed. Over here let's simplify. This is thrice of sin x minus cos x whole square. This is a square plus b square minus 2 sin x cos x whole square. Then you have plus 6. Now sin square x plus cos square x is 1. 2 sin x cos x is sin 2x. So you get 1 plus sin 2x. Then you have plus 4. A cube plus b cube is a plus b whole cube. Sin square x plus cos square x whole cube. That means 1 whole cube, which is 1. Fine. A cube plus b cube is a plus b whole cube minus 3ab, 3a b into a plus b. A plus b means sin square x plus cos square x, which is again 1. So this into 1 makes it just this much. So I am not going to write that. It's just 1. Over here come again. Sin square x plus cos square x is 1. 2 sin x cos x is sin 2x. So I am going to write it as thrice of 1 minus sin 2x whole square plus 6 sin 2x plus 4 minus 12 sin square x cos square x. Now over here again you have a minus b whole square. Open it up. A square plus b square minus 2ab plus 6 sin 2x plus 4 minus. Now see, here it is, I can reframe it as 2 sin x cos x. How? If I just break it as 3 into 4 sin square x cos square x. I can write it like this. 3 into 4 is 12. 4 can be written as 2 square. So you have 2 square sin square x cos square x, which means 2 sin x cos x whole square. That means sin 2x whole square, which is sin square 2x. So I am going to now next write it as 3 plus 3 sin square 2x minus 6 sin square or sin 2x minus 6 sin 2x plus 6 sin 2x plus 4 minus 3 2 sin x cos x whole square, which is sin square 2x. Fine. Now see, here you have plus 6 sine 2x, this is minus 6 sine 2x. Then this is plus 3 sine square 2x minus 3 sine square 2x. You have 3 plus 6, that's 9, 9 plus 4, that is 13. So such an expression is actually boiling down to this natural number, which is 13. The option, therefore, correct one is C. Understood? That's how just by rigorous use of basic identities and trigonometric identities, you can very easily complete this question. Let's look out for the next one. Which of the following numbers is a rational number? Now see, when we have dealt with trigonometric ratios of some important angles which are not one of the basic angles like 0, 30, 45, 60, 90. At that time we had dealt with 15 degrees, 18 degrees, 75 degrees, 36 degrees, 72 degrees, 54 degrees. And what are the trigonometric ratios of all these so not basic angles? Based upon that particular concept, I have to deal with this question. Now sine 15, what is sine 15? Sine 15 degrees is root over 2 minus root 3 whole upon 2. Well, you can simplify it in other steps also, in other ways also, and you are carefully and very, very evidently able to see that this is an irrational number. Q complement. That means R minus Q. Q is the set of rational numbers. From the reals you remove rationals, you get irrationals. So sine 15 belongs to the set of irrationals. What about cos 15? Cos 15 we know is root over 2 plus root 3 by 2, again an irrational number. The question is which one is rational? So definitely this is not rational. Then you have this is not rational. Next you have sine 15 cos 15 and sine 15 cos 75. Let's deal with sine 15 cos 75. Now see, sine 15 cos 75. Sine 15, how can you write cos 75? As cos of 90 minus 15, right? But cos 90 minus theta is sine theta. So this is sine 15 into sine 15. Sine 15 is this, root over 2 minus root 3 whole upon 2 into root over 2 plus root or 2 minus root 3 whole upon 2. What are you going to get? This is nothing but 2 minus root 3 whole upon 4, isn't it? Because it is root over 2 minus root 3 whole upon 2 whole square. The whole square cancels the root of the numerator and squares the 2 of the denominator. You get 2 minus root 3 upon 4, which is again irrational. That means even this is not rational. So obviously we are left with one option. That has to be correct. This is only a rational number. Let's still try to see why this is rational. Now see, you have sine 15 cos 15. Either what you can do is you have the values of sine 15 cos 15, you can multiply both of them and see the answer is 1 by 4, which is rational, or alternatively what you can do is apply the trigonometric identity. 2 sine A cos B is sine 2 sine A cos A, that means sine 2A. So sine 2 into 15, which is sine 30, which is 1 by 2 into 1 by 2, which is 1 by 4, very much a rational number. Understood? And so you have sine 15 cos 15 is a rational number, whereas all the rest of the three are irrationals. Fine? Let's now see what happens to be the next question of discussion. We are given tan theta is minus 4 by 3, then for the same theta, what do you think will be the nature of sine theta? Now see, these questions do not demand a lot of computation, they just demand a lot of concept clearance. How? tan theta is minus 4 by 3. That means it is negative. If I make you recall the sign convention, this was the first quadrant, second quadrant, third quadrant and fourth quadrant. You know there was a sign convention like all, school, to, college, ASTC. All positive, sine positive, tan positive, cos positive, right? So over here, if tan theta is negative, see, tan is positive in the first and third. In the first, all are positive. In the third, tan is positive. That means if tan of some theta is negative, theta is lying either in the second or in the fourth quadrant. Theta lies in second or fourth quadrant. Right? Question is, what about sine theta? Fine? Now, see, in the second and fourth quadrant, what is the nature of sine theta? In the second quadrant, sine theta is positive. In the fourth quadrant, sine theta is negative. Therefore, for the same theta, sine theta is positive or negative. If theta lies in the second quadrant, sine theta is positive. If theta lies in the fourth quadrant, sine theta is negative. So it is either positive or negative. Over here, let's see. It is saying sine theta can be negative but not positive. It can be positive. Sine theta can be negative or positive. Yes. Sine theta is positive but not negative. It can be none of the above. Of course, wrong. Understood? So this question did not basically ask you to compute what is sine theta. Here only the game is of signs. If you are aware about the sign convention, ASTC rule, you will be able to do this question within no time. It's a very easy, direct, concept-based question which is trying to confuse you with the help of values given. Let's see what happens to be our next question of discussion. Moving to the fourth question, we are given sine 12, sine 48, sine 54. Give me the answer. Again, you can see the angles involved are not basic angles, right? Not 0, 45, 30, 60, 90. I personally call them good looking angles. So they are not so good looking angles. Let's see how, with the help of trigonometric identities and all the formulas that we have, we can convert them somehow into the basic good looking angles and then plug in the values to get our result. So we have sine 12, sine 48. And then you have sine 54. Okay, 2 at a time. Fine. I multiply by 2 and divide by 2, I get 2 sine 12 sine 48 into sine 54. What is 2 sine A sine B? It is cos of A minus B minus cos of A plus B. Right? 2 sine A sine B is cos of A minus B minus cos of A plus B. I am just treating this as A and this as B. What is 48 minus 12? This gives you 36 minus cos 48 plus 12. This gives you 60. Fine? Now see, cos 36 I don't know, but cos 60 I know. It is what? 1 by 2. So you get 1 by 2 cos 36 minus 1 by 2 into sine 54. Fine? Multiply sine 54 inside, what you get? 1 by 2 cos 36 sine 54 minus 1 by 2 sine 54. Okay? Now see, if you multiply and divide by 2, you are going to get 1 by 2 here, 2 here and 2 here. 2 is going to cancel this 2. You will be having 2 sine 54 cos 36 minus sine 54. See what you're getting? This is 1 by 4. 2 sine A cos B is sine of A plus B plus sine of A minus B. So it is sine of A plus B plus sine of A minus B minus sine 54. Fine? What does this give you? 54 plus 36 is 90, sine 90 is 1. 54, so this is 90. What is this? 18. I know what is sine 18? Root 5 minus 1 by 4. And what is sine 54? Root 5 plus 1 by 4. What you get? 4 is the LCM, so 4 plus root 5 minus 1 minus root 5 minus 1 whole upon 4 plus root 5 minus root 5 gets cancelled. You have 4 minus 1, that's 3, 3 minus 1, that's 2, 2 upon 4, or you get 2 upon 16, which is 1 upon 8. Let's search for the solution. You have 1 upon 8 sitting as option B, which happens to be correct. And so, here we combated this particular problem by having the knowledge of some non-basic angles, which was sine 18, sine 54. Fine. And apart from that, we just should know the transformation formula, how to convert product into sum into product. Just these basic things are enough to get to the correct solution 1 by 8. Understood? Let's see and deal with the next question. Question number 5 is trying to say in any triangle. Now the moment I am talking about triangle, the topic is solutions of triangle. So in any triangle, you are having 3 angles A, B and C. You know the side opposite to angle A is denoted by small a, side opposite to angle B is small b, side opposite to angle C is small c. Based upon the same convention, it is trying to ask you to compute the value of cot A by 2 plus cot B by 2 plus cot C by 2. What are you going to do to compute this value? Okay, so in any triangle, cot A by 2 plus cot B by 2 plus cot C by 2 is what? Now see, we know A plus B plus C is pi, isn't it? In any triangle, A, B, C, these are itself the name of the angles also. This is A, this is B and this is C. I know sum of all 3 angles is 180 degrees. So A plus B plus C is pi radians. That means A by 2 plus B by 2 plus C by 2 is pi by 2. Right? What about A by 2 plus B by 2? A by 2 plus B by 2 is pi by 2 minus C by 2. Therefore, cot of A by 2 plus B by 2 will be cot of pi by 2 minus C by 2. Cot of 90 minus theta is tan theta. And what is cot of A plus B? Cot A, cot B minus 1 upon cot A plus cot B. So you have cot A, cot B minus 1 upon cot A by 2 plus cot B by 2. I just use the formula of cot of first angle plus second angle is cot of the first angle into cot of the second angle minus 1 upon cot of the first angle plus cot of second angle. Everything is in terms of cot, so I can write tan C by 2 as 1 upon cot C by 2. Fine. Now just cross multiply, what you get is cot A by 2, cot B by 2, cot C by 2 minus cot C by 2 is equal to cot A by 2 plus cot B by 2. Fine. Take cot C by 2 that side, what you get is cot A by 2 into cot B by 2 into cot C by 2 is cot A by 2 plus cot B by 2 plus cot C by 2. A very interesting result which you can even try to memorize. Here you are taking product of cot A by 2, cot B by 2 and cot C by 2, and this result which you are getting by taking the product of cot A by 2, cot B by 2, cot C by 2, where A, B and C are angles of a triangle, the result is the same when you add these three quantities. So take the product or you add them, you get the exact same answer. Isn't that fantastic? And therefore, your answer happens to be what? Cot A by 2 plus cot B by 2 plus cot C by 2 is cot A by 2 into cot B by 2 into cot C by 2. Understood? That is how easily, just by using one basic property of triangle, that sum of all three angles of a triangle is 180. Then we proceeded with divided by 2 because we have to talk about half angles, and then just by using this very formula of cot of A plus B, I am through. After that, it's just cross multiplication, simplification, and you get your answer. Fine. Let's see what happens to be the next question. You have a vertical tower given to you. Let a vertical tower AB have its end A. End is A on the level ground. So the end A is on the level ground. Let's see. Level A is on the level ground, that means this is A and this is B. Its end A on the level ground, let's see be the midpoint of AB. So suppose this is my point C, this is the midpoint. And P be a point on the ground such that AP is twice of AB. So somewhere on the ground, so A is already on the ground level, somewhere P is on the ground such that AP is twice of AB. So suppose AB is H, then AP is 2H. Fine. Let AB be H, so AP is 2H because AP is twice of AB. If angle BPC is beta, okay, so BPC, that means if this angle is beta, then tan beta is equal to what? Now see, this is how the structure is given to me. Over here it is evident this angle is 90 degrees. Suppose I say this angle is some angle alpha. Just take it to be alpha. Now over here it's very evident to use the tangent ratio. That's what we do. Tan. If I talk about in triangle APB, the biggest triangle I am talking about, it's a right angle triangle. I can talk about the tangent ratio. Tangent ratio of this angle I am interested. Tangent ratio of this angle will be AB upon AP, right? Through proper brushing perpendicular upon base. So you have tan of this angle, which is alpha plus beta, is equal to AB upon AP. AB is H, AP is 2H, you get 1 by 2. Next, let's focus upon APC triangle. Again a right triangle. In triangle APC, what is tan alpha? It is AC upon AP. Now AP I know it is 2H. AC is what? Because C is the midpoint, AB is H, so this is H by 2 and this is H by 2. Half of H because C is the midpoint of AB and AB is of length H. That means AC is H by 2. What you get is H by 2 into 2H 1 by 4. Question is compute tan beta. Directly I cannot compute tan beta like I am able to compute tan alpha or tan alpha plus beta, because this beta is not the acute angle lying in a right triangle. So indirectly we will have to compute beta. So what will happen? Tan beta will be tan of alpha plus beta minus alpha, right? Tan of alpha plus beta minus alpha can be written as tan beta. This alpha gets cancelled. Now tan of A minus B is tan A minus tan B upon 1 plus tan A tan B. Fine? Tan A minus tan B upon 1 plus tan A tan B is what is the formula of tan of A minus B. Now I know about tan of alpha plus beta, I know about tan alpha, again I know everything, just plug in the values. What you get? Tan of alpha plus beta is 1 by 2 minus tan alpha is 1 by 4, 1 plus 1 by 2 into 1 by 4, that's 1 by 8. So what you get? 2 minus 1 upon 4 whole upon 8 plus 1 upon 8. This gives you what? 1 by 4 multiplied by 8 by 9, which gives you what? 2 by 9, and therefore tan beta is nothing but 2 by 9. That's how easily this question got accomplished. Here we could see two right triangles corresponding to both the right triangles ABP and APC. We applied the tangent ratio formula and we obtained the value of tan of alpha plus beta and tan alpha. Then we expressed beta in terms of alpha plus beta and alpha. Application of formula, just plug in the values, you have your answer. So your answer is what? 2 by 9. Fine. Let's watch out for the next question. 7th question is asking you to compute the general solution of an expression. Take a look at it, try to see what the question is demanding. Okay friends, so I hope you have seen the expression very nicely. Let's see what is that expression. I can alternatively write it as sine 3x plus sine x minus 3 sine 2x equals cos 3x, so there is a symmetry, plus cos x minus 3 cos 2x. Fine. Over here it's very evident, see, sine C plus sine D. 2 sine C plus D by 2 cos C minus D by 2 minus 3 sine 2x. Then on the right hand side you have cos C plus cos D. 2 cos C plus D by 2 cos C minus D by 2 minus 3 cos 2x. Fine. What will this expression be equal to? 2 sine 3x plus x, 4x. 4x upon 2 gives you 2x. Cos 3x minus x, 2x. 2x upon x gives you just x minus 3 sine 2x equals 2 cos, again 3x plus x, 4x. 4x upon 2, 2x. So you get 2 cos 2x into cos x minus 3 cos 2x. Fine. Over here you can see sine 2x is sitting as a common expression. So I can take this out. What you get is 2 cos x minus 3 inside. Here you can see there is cos 2x sitting common. So you can take cos 2x out. You get 2 cos x minus 3 again. Fine, just take every expression, bring every expression on the left hand side. What you get is 2 cos x, so this will be sine 2x into 2 cos x minus 3 minus cos 2x into 2 cos x minus 3. 2 cos x minus 3 is going to come out common. And what you get is sine 2x minus cos 2x equals 0. Product of two things is 0 provided either this is 0 or this is 0. Can this be 0? 2 cos x minus 3 is 0, that means cos x is 3 by 2. That means cos x is 1.5. But cos x, cosine function, is less than equal to 1 for every x. Therefore, it can never be equal to 3 by 2. It can never be equal to 1.5. That means 2 cos x minus 3 can never be equal to 0. If this is non-zero but the product is 0, this means this factor has to be 0. Only then the product will be 0. So, sine 2x minus cos 2x has to be 0. That means sine 2x should be equal to cos 2x. I have to find those x's for which sine 2x equals cos 2x. This means I have to find those x's for which tan 2x is 1. I can bring cos 2x in the denominator. I have tan 2x equals 1. Well, now is the time to recall the general solution of tan theta equals tan alpha, where alpha I can say is an angle in the principal domain of the tan function, is theta equals n pi plus alpha, n in the set of all integers. And therefore, tan 2x equals 1, which is tan pi by 4. Pi by 4 lies in the principal domain of tan function, which is minus pi by 2 open interval. And it is the only angle in the principal domain where tan function can be 1. Fine, or I can say this is the smallest angle, smallest positive angle, or basically smallest such angle at which tan theta is 1. Such alphas we plug. So, tan theta equals tan alpha, which means theta equals alpha plus n pi. This means what is x equal to then? X is equals to n pi by 2 plus pi by 8, and that is what is your solution. All those x which are equal to n pi by 2 plus pi by 8, for them these two will be equal, for them this product will be 0, for them this will be equal to this. So, n pi by 2 plus pi by 8 is our solution or general solution, which is given as this. Obviously, n is ranging over the set of integers. So, that is how you compute the general solution of this given expression. Let's move forward. Watch out for the next question, question number 8. Over here, question number 8 is saying the number of integral values of k for which the equation 7 cos x plus 5 sin x equal to 2k plus 1 has a solution is what? So, what are the number of solutions for such a given expression? Over here, if you can see, I am having a very standard form of a trigonometric expression given to me. A sin x plus b cos x. Is there anything you can recall about this expression? Well, for any x, a sin x plus b cos x had a maximum value and it also had a minimum value. What was that? Well, a sin x plus b cos x was always greater than equal to minus under root a square plus b square and was always less than equal to under root a square plus b square. That was what was always true. Fine. So, over here if I have 5 sin x plus 7 cos x, this will be greater than equal to minus under root 25 plus 49 and less than equal to under root 25 plus 49. This means 5 sin x plus 7 cos x will be less than equal to root 74 and greater than equal to minus root 74. Now, root 74 is almost equal to 8.6 something. So, here you will have minus 8.6, which is strictly greater than minus 9, and this is strictly less than 9. So, I can write this as 5 sin x plus 7 cos x is strictly less than 9 and strictly greater than minus 9. Why did I do that? Because you are interested in finding the integral values. So, I don't want to deal with decimals. Let's try to deal with integral values. You want all such integral values of k for which these two are equal. Now, 7 cos x plus 5 sin x is given to me to be equal to 2k plus 1. So, k is such that k is all those integers such that 2k plus 1 is less than 9 and greater than minus 9. Take this one, what you get is 2k is greater than minus 9, minus 1, that's minus 10, and 9 minus 1, that is 8. So, k is such that k is an integer such that minus 10 by 2 gives you minus 5 and 8 by 2 gives you 4, such that k is strictly greater than minus 5, strictly less than 4. So, over here if you try to picture the number line, this is 0, this is 1, this is 2, this is 3, this is 4, and here you have minus 1, minus 2, minus 3, minus 4 and minus 5. K is an integer strictly greater than minus 5. So, it can be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. Can it be 4? No, it is strictly less than 4. So, it can at most go up to 3. It can be equal to only these integers, strictly greater than minus 5, strictly less than 4. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. Therefore, k can take 8 values. So, there are 8 possible values of k, possible integral values of k, for which 7 cos x plus 5 sin x equals 2k plus 1. So, the answer is 8. Understood? That's how this easy question was dealt with, just by the usage of this particular concept, because the moment I saw this 5 sin x plus 7 cos x, the first thing which popped inside my brain was it is resembling this general form a sin x plus b cos x, about which I knew the maximum and minimum output. Okay? Let's go and see what happens to be the next question. Question number 9 is again trying to ask you the number of solutions. The number of solutions of a trigonometric equation which is sin x equals x by 10 is what? Now see, there are many ways to do this question, but I would personally suggest, because sin x is a function whose graph you are very nicely aware about, x by 10 is nothing but a straight line which can easily be plotted by you by just the use of 2 points. You can just join those 2 points, get the entire line. So, it's better that we see where all does the graph of sin x and x by 10 intersect each other. Wherever at all those points where these two graphs are intersecting gives me all the possible number of values of x for which sin x will be equal to x by 10, right? So, let's use the graphical approach. Okay? So, what can I say over here? I know sine function goes like this. Fine. So, here also, let me extend this a bit. You can draw for your comfort zone as many oscillations as you feel are necessary to deal with the question. Fine? So, this is your sin x. In the same plane, I will be drawing the graph of y equals x by 10 and see where is it intersecting. Now, see, you should be very well aware that the maximum value which the function can take is 1 and the minimum that it can take is minus 1, right? If I talk about y equals x by 10 If I put x equals 1, I am going to get y equals 1 by 10. Now if I go and plot 1 by 10 somewhere, I might commit a mistake in plotting it somewhere below the graph of the sine function or above the graph of the sine function, right? So it's better to plot such values of x, take such values of x for which y gives you integral answers. Fine, because you know one thing in terms of integers, that the maximum integer which the sine function can take is 1 and the minimum is -1. So what are the integral values of x for which y can give you an integer? Well, if you take x to be multiples of 10, y is going to give you an integer. For x equals 10, y is 1. And I know this line is always going to pass through origin. For x equals 0, y is 0. I have got 2 points, 10, 1 and 0, 0. 2 points are enough for me to plot the line. 10, 1. Now where is this 10? This is 0, this is pi, this is 2 pi, this is 3 pi. Now what is 3 pi? 3 pi is 3 into 3.14, which is 9.42. That means 10 will be somewhere here. Fine, 10 will be somewhere here. This is your 10. Now at 10 the function is attaining the value 1 over here. Fine. Now understand carefully. This is one point on the line. This is another point on the line. This is the point where this elevation is same as this height. But before that, never ever at any point before 10 will x by 10 be equal to 1. It will always be less than 1. From 0 to 10, x by 10 will always be less than 1. At 10, it will be equal to 1. Beyond 10, it will be greater than 1. And so, what are you going to get is such an answer. This is what happens to be the graph. But if you say, what if I make one more oscillation and this also cuts the graph of sine further? I am going to say, no, it cannot cut, because the moment you plot x by 10 for points greater than 10, this will attain the value greater than 1. And sine x cannot go greater than 1. That means never ever beyond this point, it is going to intersect the sine function. Because sine function is going to be elevated up till 1, but this line is going to go beyond 1, so they are not going to intersect. Similarly, it is a symmetric type of a function, odd function. So what are you going to get? Like this. Behind, again, this is not going to touch this axis, touch the graph of the sine function here as well. Fine, it is going to go without touching the function of sine. And here also it is going to go like this without touching the graph of sine. That means how many points is it cancelling? 1, 2, 3, 4, 5, 6 and the origin is 7. There are 7 solutions. There are 7 solutions of sine x equals x by 10. So there are 7 x's for which sine x equals x by 10. This is one of the x1, I'll say this is x1, this is some x2, this is x3, x4 is 0. Then you have this one, this is x5, this is x6 and this is x7. So these are your 7 x's for which sine x equals x by 10 and therefore the solution is 7. What is the number of solutions? There are 7 solutions. Understood? Let's proceed and see what is the next question. The next question is trying to talk about again a triangle. It is saying in triangle ABC, the area of triangle is given by this. Then what about tan A? Okay. So for this I should be aware about all the different formulas of area. Over here you can see if I generally draw the triangle, this is my A, this is my B, this is my C. Similarly, angle A, angle B, angle C. This is A, this is B and this is C. Then if the area is given to me in terms of sides, I am bound to use my Heron's formula. Area of triangle ABC is under root S into S minus A, S minus B, S minus C, where A plus B plus C is 2S. Therefore, A plus B plus C by 2 is S. Semi-perimeter and perimeter. This is your perimeter and this is your semi-perimeter. Fine. So this is what is the formula which basically we should be using because the area is given to me in terms of sides. Now what is it that you have? Area of triangle is A square minus B minus C whole square. Okay, area of triangle ABC is A square minus B minus C whole square, which is A plus B minus C and A minus B plus C. A square minus B square is A plus B into A minus B. So A minus or A plus B minus C and then A minus B plus C. Now see, if A plus B minus C is something I want to compute. So I can write it as A plus B plus C minus 2C. A plus B is 2S minus 2C, which is twice of S minus C. So I can write here twice of S minus C. Then A minus B plus C. I can write it as A plus B plus C minus 2B, which is 2S minus 2B, which is twice of S minus B. So twice of S minus B. Fine? That is how I simplified this expression, which gives you what? 4 S minus C into S minus B. But area of triangle in the form of Heron's formula I know is equal to this. So on the left hand side, in place of this expression, I can write my Heron's formula, which is what? Under root S into S minus A, S minus B, S minus C is equal to 4. I can write this as under root S minus C, under root S minus C, under root S minus B, under root S minus B. Because over here everything is an under root and I want to cancel terms. So I am going to write S minus C as under root S minus C, under root S minus C, under root S minus B, under root S minus B, which is S minus B. So what you are going to get, you have under root S minus A, under root S minus B, under root S minus C equal to this same expression. So from here you cancel out 1 under root S minus C and you cancel out 1 under root S minus B. What are you left with is under root S into S minus A equals 4 times under root S minus B into S minus C. Right? Now what can you do is, this implies under root S minus B S minus C upon under root S into S minus A is 1 by 4. This upon this is 1 upon 4. Now what is this? S minus B, S minus C. So basically what you have is S minus B, S minus C whole upon S into S minus A equals 1 by 4. What is this? What is this? This is nothing but tan of A by 2. Remember the half angle formulas in terms of sides? We have done that. This is equal to 1 by 4. Well, I have got the value of tan A by 2, but I do not want tan A by 2, I want tan A. So how am I going to compute tan A? So tan A, can it be expressed in terms of A by 2? Well, I know tan 2A is 2 tan A upon 1 minus tan square A. So what is happening? Angle was twice, it is being halved. Therefore, tan A will be 2 tan A by 2 upon 1 minus tan square A by 2. What is tan A by 2? Tan A by 2 is 1 by 4. So, twice of 1 by 4 whole upon 1 minus 1 by 4 whole square, which is 1 by 16. So, you get 1 by 2 divided by 16 minus 1, 15 by 16. Or you can write it as 1 by 2 into 16 by 15. What you get is 8 by 15. So your tan A is coming out to be 8 by 15. Let's see if it is there. Yes, it is there as the first solution. Fine. So this is how area of triangle was used from the topic solutions of triangles to basically form this question, frame this question, and therefore everything related to that you should be very well aware about to be able to mark the correct solution for this question. That's it. We have completed our discussion. I suggest you to take a good practice of all these questions because they are really important. Thank you. That's it for today.